All right, so now we'll continue with our factoring with lead coefficients other than 1. Try these 3, go ahead. So these guys here, of course you did stop and start. These guys here are clearly the most difficult kind of factoring that there is. For the first one, I do not see a greatest common factor of 2, so that's when I take the lead coefficient and I multiply it by the last term. And that gives me x squared plus 5x plus 4, right? Because this 2 in front goes here, 2 times 2 is 4. We've been over this a number of times, so I'm starting to go a little quicker with it. Factor that, x plus 1, x plus 4. But look, we changed this question when we multiplied it by 2 and got rid of the 2 in front. So we have to balance that out by coming back and dividing by 2. If I do that, I get x plus a half and x plus 4 over 2. 4 over 2 is 2. And then if you can't reduce the fraction, we do the elementary school improper fraction mixed number trick, multiplying by that 2 in front of the x. So I get 2x plus 1 times x plus 2. If I multiply back, 2x times x is 2x squared. 2x times 2 is 4x's. 1 times x is 1x. 4x and 1x make 5x. And 1 times 2 is 2. So it works. Of course, you should have done stop and start before we reviewed that one. If you did not, and you just allowed me to go through the explanation, then I would strongly suggest you do stop and start now. Okay, so stop and start complete. We take a look at number 9 here, and what I notice is that there's a lead coefficient other than 1, which makes me go into my secondary approach. And I look for a greatest common factor of 3, nowhere to be found. So I go to plan B. Multiply the last term by 3. So the 3 comes out of the front, multiplies here. That gives me x squared plus x minus 12. Factor that. X plus 4x minus 3. Now come back in, and since I multiplied by 3, now I have to divide both terms by 3. That's how I balance out my maneuvers. 3 over 3 becomes 1, and then there's the elementary school trick. 3 times x is 3x plus 4. So 3x plus 4 times x minus 1. If I distribute back, 3x times x is 3x squared. 3x times negative 1 is negative 3x. 4 times x is 4x. Negative 3x plus 4x is 1x. 4 times negative 1 is negative 4. All right, number 10. I look for a 5 for a greatest common factor. It's not there, so I go to plan B. Multiply the last term by the leading coefficient of 5. That gives me n squared plus 7n, or x, doesn't matter, minus 30, because 6 times 5 is 30. Just factor that. X plus 10x minus 3. Then come back in and divide both sides by 5. And I can simplify. 10 over 5 is 2. And then I have to do the elementary school trick, put the 5 in front, 5x minus 3. Distributing back, x times 5x is 5x squared, x times negative 3 is negative 3x's. 2 times 5x is 7x, 2 times 5x is 10x. 10x and negative 3x makes 7x, and 2 times negative 3 is negative 6. So bingo, it works. Lights flash, bells ring. I did my check back. Okay, that's supposed to be a minus in between. 2n squared minus 10n plus 8. So factor each of these terms. Go ahead. Okay, so on the first one, I look for greatest common factor, and oh boy, there it is. I'm loving it. Factor out that 2. Now I just factor x squared minus 5x plus 4. That's x minus 1, x minus 4. Don't forget the 2 in front. That is my factoring complete. If I distribute back, x times x is x squared. X times negative 4 is negative 4x. Negative 1 times x is negative 1x. Negative 4x and negative 1x makes negative 5x. That's what I wanted. Negative 1 times negative 4 is 4. Then I distribute the 2 back, and I get to my 2x squared minus 10x plus 8. And that works perfectly. When I try number 12, again, there's a 2. I love it. That's 2 times x squared plus 3x. I'm using an x instead of h, sorry. Minus 40, right? Everything was cut in half. Factoring that, I get x plus 8 times x minus 5, and then times 2 in the front. I'm not going to check back at this point, but I know you know how, and you can check it yourself. All right, now we look at number 13, and I'm like, oh man, this will be great. Let me find the 4. Oh, darn man, there is no 4. So that's where I go to plan B, and I distribute the 4 back. I multiply the 4 by the last term and go from there. In case you didn't do it before you checked your answer to the last one, I'm going to give you a few seconds. You pause the video, of course, to get it done. Okay, so I'm going to multiply. I look for the greatest common factor. There is none, so I multiply the last term by the leading coefficient. That gives me x squared minus x minus 12. I can factor that with AM or the calculator. It gives me x plus 3 times x minus 4. But you have to remember, you changed the question. So go back in and divide by that 4 you multiplied by. X plus 3/4, x minus 4 over 4. 4 over 4 is 1. And then the elementary school trick, 4 times x is 4x. Plus 3 times x minus 1. And we are all set. Okay, so now we're on to quadratic equations, and they explain some things mathematically, like, for instance, bridges. You can see this shape is called a parabola, and if we graph a quadratic, like what's in bright blue here, we would be creating a parabola, and you can see that the x term is squared. If you track the path of an object through the air, you get a parabola. It could be, in this case, someone doing fancy tricks on a bike, or it could be fly balls to the outfield, a kick from a field goal kicker or a soccer player, anything like that. Okay, and last but not least is you can look at this arch here. This is a place up by where I live. It's called the Stone Arch in Jeffersonville, and you can see the shape of that arch is parabolic also, which reflects a quadratic equation. So these equations do reflect a number of things that you're liable to see in the real world. Now, some quadratic equations are really simple. A quadratic equation just means that the highest exponent there is a 2. And if I said, hey, x squared is 9, you'd say, oh, it could be positive 3, or it could be negative 3. Really, really, really simple question. Just square root both sides. We're not going to be quite that easy. For example, what if it looks like this? Well, now we're just going to use factoring. So the really cool thing is, if you were good at factoring, which was last week's lessons, then quadratic equations are pretty simple for you. What I'd like you to do on this first equation on the left is ignore the equals 0 for now, okay? Just factor x squared plus 8x plus 15 and then stop. Okay, I assume you did stop and start. So if I factor that, I'm going to get x plus 3 times x plus 5. Now, since we're into equations, I'm not going to explain every factoring for you. You should be able to understand. You use either AM or the calculator. Now, here's the thing. X plus 3 is a term, if you will. X plus 5 is kind of like a term, if you will. The first term times the second term is 0. So if I have two things, terms, and if I multiply them to get 0, what does that tell me? Well, before we think of the terms, let's think about numbers. If I multiply any two numbers and the answer to the multiplication, the product, is 0, what can you tell me about those numbers? Well, one of them or both of them have to be 0. The only way to get 0 with multiplication is that at least one of the things being multiplied has to be 0. For example, 5 times 4 will never get you 0. 5 times 0.0001 will not get you 0. But 5 times 0 will get you 0. Or 0 times 0. So maybe it's one of them, maybe it's both of them. And what we're going to do now is we've gotten to the point where this term on the left, this thing, x plus 3, that could be 0. Or this thing, this term, x plus 5, that could be 0. So maybe it's the binomial on the left. Maybe it's the binomial on the right. I don't know which one it is. Maybe it's both. Who knows? And then I just solve each of those independently, subtracting 3s, subtracting 5s, and I get x is -3 and x is -5. And those are the answers. So what is the strategy in summation? Just factor it. And then remember, since it says equals 0, maybe it's the guy on the left, maybe it's the guy on the right. Solve them each independently. So you try the middle one now. Go ahead. Stop and start. Okay. So if I factor this x squared minus 7x minus 18, I get x minus 9 times x plus 2. Maybe it's the guy on the left. Maybe it's the guy on the right. Solving the one on the left, I add 9. Solving the one on the right, I subtract 2. X equals 9. X equals -2. Brings up an interesting point. This is called a quadratic because of the exponent of 2 here. You would think it would be 4. There's a pretty involved explanation as to why we call it a quadratic when the highest exponent is 2. I'm not going to get into that explanation now. But bottom line is, if the exponent is 2, it's possible to have 2 answers. Exponent's 2, possible to have 2 answers. Sometimes it's one answer that repeats itself, so it's kind of like 2 answers. Now, do you notice anything different between this last question and the 2 previous questions? Well, in the 2 previous questions, they both said equals 0. This one does not say equals 0. And we are solving quadratic equations by factoring. So I have to subtract 12 from both sides. That gives me x squared minus x minus 12 equals 0. And now I factor, just like I did on the previous ones. Go ahead. Okay, so I factor it. X plus 3 times x minus 4. Maybe it's the guy on the left equals 0. Maybe it's the guy on the right equals 0. On the left, we subtract 3 from both sides. On the right, we add 4. And that gives me x equals -3 and x equals 4. And look, if you plug it in and check it, I'm just going to check the 4. 4 squared is 16. Minus 4 is 12. 12 equals 12. It checks. If I go to the middle one, I'm just going to check the 5. Oh, the 9, I'm sorry. 9 squared is 81. Minus 7 times 9 is 63. 81 minus 63 is 18. 18 minus 18 is 0. So it checks. So once again, here we are solving quadratic equations. We can get 2 answers now because the exponent is 2. And the other thing is, we always want to make it, for now, because we're solving by factoring, equal to 0. All right. So let's see you try all 3 of these. Remember, you've got to get it to equal to 0. So hint, hint, hint on the first one, subtract your 8x from both sides. So I would do them one at a time and we'll go over the answers, but you're going to do all 3 of these without me. Go ahead. Okay, so I subtracted the 8x, and you want to get it in that standard polynomial form. See, there it is. Highest exponent of 2, then exponent of 1, then the number. That's very important now because it allows us to factor. If we factor x squared minus 8x plus 15, it's x minus 3 times x minus 5. Maybe it's the guy on the left equals 0. Maybe it's the guy on the right that equals 0. Add 3 to both sides on the left, add 5 on the right. X equals 3, x equals 5. So, moral to the story, strategy to use, get everything equal to 0, standard polynomial order, factor. Go ahead, try the next one in the middle. Now you're going to have to get the 18 and the -7x over to the other side. Okay, so I subtract 18 from both sides and I add 7x to both sides. But be careful when you put it all together. This 18 is negative, the 7x is positive, and the x squared is positive. So positive x squared, positive 7x, negative 18. We factor now. X plus 9 times x minus 2 is equal to 0. Maybe it's the guy on the left. Maybe it's the guy on the right. Subtracting 9, adding 2. X is negative 9, X is 2. Okay. Last but not least, go ahead. Okay, so we're going to subtract the 12. That gives me x squared plus x minus 12 equals 0. Factor. X minus 3 times x plus 4 is 0. Maybe it's the guy on the left. Maybe it's the guy on the right. Adding 3 on the left, subtracting 4 on the right. I get x equals negative 3. Positive 3. Why does that say negative 3? I don't know. That must have been left over from the last term. X equals positive 3 and x equals negative 4. So, the happy recap. What we covered today. Quadratic equations. What are the steps to solving a standard quadratic equation? First step, set that trinomial equal to 0. That means get everything on one side, standard polynomial order. Factor it, solve. Now, there are other ways, and we'll get into those on our next lesson, which will be the more involved cases. Today is the fundamental simple cases. Have an awesome day. Don't forget, quiz next lesson, and don't forget to get that homework done. See ya. Bye.